Hi, welcome back. So for this video, we are going to discuss the normal probability distribution and hypothesis testing. So you will find bivariate analysis and linear regression in another video. So the normal probability distribution is a probability distribution for continuous variables. Figure 1 here is an example of what a normal probability distribution might look like. It is also known as Gaussian distribution. It's a bell-shaped curve. The probability is an event occurring is greater in the center of the curve and decline for events at each of the two ends, or called tail of the distribution. Characteristics of the normal distribution are, first, it's a bell-shaped, unimodal, symmetrical. And second, the tails never touch the axis, means they go both positive and negative infinity. You may keep in mind that normal distribution is a theoretical probability distribution, so it makes sense that tails extend to infinity. The normal distribution is defined by a mathematical equation, and it is not an empirical distribution. In this example, the curve represents the height of Canadian males. Adult males can be short, average, or tall, or anywhere in between. Y-axis represents the relative probability of observing someone who is really short or tall. So for example, it's relatively rare to see someone who is super tall. So the bell-shaped curve is relatively low on the far right tail. But it is common to see someone who is close to the average height. So the bell-shaped curve is very tall in the center region. The mathematical formula for the normal distribution or the normal probability density function is here. We will not work on the formula directly, but we need to remember something. The normal distribution is defined by two parameters, the mean, mu, and the standard deviation, sigma. Mu is the mean of the continuous variable x. The mean defines the location of each normal distribution. Increasing the mean shifts the curve to the right. The standard deviation sigma defines its shape. You may think, does it mean there are many normal distributions? My answer is yes, you are right. There are many normal distributions. These normal distributions differ in terms of their mean and variance, or both of them. Okay, with basic knowledge of normal distribution, we are going to discuss the knowledge you will use hypothesis testing. In this slide, we will learn how to use sample statistics to make decisions about the population parameter. This procedure is called statistical hypothesis testing. Again, how to use sample statistics in one study to make decisions about the whole population parameter. This procedure is called statistical hypothesis testing. A hypothesis is an assumption or claim about some characteristic of a population which we could be able to support or reject based on empirical evidence. A hypothesis is usually defined in terms of interrelations between variables and is often based on a substantial theory or broadly say research literature review. A hypothesis is a tentative answer to research questions. They are tentative because we can find evidence only after being empirically tested. The testing of the hypothesis is an important step in the evidence collection process. So let's draw a random sample of Ontario gas stations, let's say 100 gas stations, to calculate the mean price of a gallon of regular gas, say $2.7. Based on the consumer information, our population, nationally, the mean price of a gallon is $2.3, and the standard deviation is 0.15 for the same week. By giving you the basic information, now we compare the mean price of gas in Ontario with the mean price of all gas stations in Canada for the same week. I'm going to ask you the question, can we assume that our random sample of 100 Ontario gas stations are representative of the whole population of gas stations in Canada? Actually, we expect to find that the mean price of gas from a sample of Ontario gas stations will be unrepresentative of the population of gas stations because we assume higher prices in Ontario. We know the sample mean $2.7 is higher than the population mean of $2.3, but it is estimated on a single sample in the study. It could mean more than two things. First, the mean price of gas in Ontario is indeed higher than the national average. Or second, the average price of gas in Ontario is about the same as the national mean. It just the sample from the 100 gas stations happens to show a high mean. So it could be mean two of the two things. So how can we decide which explanations from the two make sense? Because most estimates are based on a single sample, and different samples may have different estimates. Sampling results cannot be directly to make statements about the population. We need a procedure that allows us to evaluate hypotheses about population parameters based on sample statistics. We did not discuss probability in this class, but statistical inference is based on probability theory. It's not possible to prove or disprove the research hypothesis directly, so we can try our best to estimate the likelihood that it is true or false. Based on the sample I just shared, a hypothesis is an assumption or claim about some characteristic of a population, which we could be able to support or reject on the basis of empirical evidence. Hypothesis testing is a process for choosing between different alternatives. We have two options to choose from. Remember, these are termed as non-hypothesis and alternative hypothesis. Non-hypothesis is the statement that is being tested, presumption that it is accepted as correct unless there's a strong evidence against it, usually representing no change or no difference, symbolized as H0. For example, the average height of male basketball player has not changed in the last 10 years. The alternatives have to be mutually exclusive and exhaustive. It is a statement that is adopted when the data is strong enough to reject the non-hypothesis. It indicates a difference, symbolized as H1. For example, the average height of male basketball player has increased since in the last 10 years. A statistical test assesses the strength of the evidence against the non-hypothesis, as we discussed in the p-value. So non-hypothesis states that there is no difference between the population mean and some specified values. It also refers to as the hypothesis of no difference. There is no difference between the population mean and some specified values. Typically involves the equal symbol. For example, the two means of the two populations are the same. Research hypothesis is symbolized as H1. They are always expressed in terms of population parameters because we are interested in making statements about the population parameters based on our sample statistic. In general, the research hypothesis is written as the population parameter is not equal to some specified value, greater than some specified value, or less than some specified value. For example, means of two populations are different. mu1 is not equal to mu2, or mean of the population 1 is larger than that of population 2. Take an example here. I would like to pause here and you will read it by yourself. So you are going to have your non-hypothesis and alternative hypothesis. The non-hypothesis is about the population parameter, mu. Mu is not the sample. It is the average amount of liquid in the bottles in the batch. Mu is the assumption of 500 milliliters. It is the actual mean for the batch and is the target needs to be. So we write mu equals to 500 milliliters. You may ask why it's not 503 milliliters. Because your hypothesis is about the population parameter. The 503 milliliters is the sample statistic and the sample mean. The alternative hypothesis is something different than 500 milliliters. So we write mu is not equals to 500. I would like to take an example here. What should be non-hypothesis and alternative hypothesis? Please pause the video and read the example. Explanations. First, we write hypothesis regarding population parameters, not sample statistic. The non-hypothesis should have a statement of equality. The direction of the alternative hypothesis depends on the context of the test. Second, in a significant test, we are looking for evidence against the non-hypothesis. In this situation, the counselor is seeking evidence to reject the claim that the average amount of sleep that students get on the weekend is 9 hours per night. So if the average amount of sleep that students at this school get per night on the weekend, the non-hypothesis is H0. Mu is equal to 9 hours. Third, the alternative hypothesis is a claim we are trying to find evidence in favor of. In this situation, the counselor tests if the average amount of sleep she heard about holds true at their school. In other words, the counselor is curious if the average at their school is higher or lower than 9 hours. So the alternative hypothesis in symbols would be HA, mu is not equals to 9 hours. So the correct answer is A. So let's take a look at another example. I will please pause the video and I will give explanations later. Okay, explanation. First, we write hypothesis in terms of population parameters, not sample statistic. The non-hypothesis should have a statement of equality. The direction of the alternative hypothesis depends on the text of the test. So second, in a test of significance, we are looking for evidence against the non-hypothesis. In this situation, the economist is seeking evidence to refute the claim that the average rent is still 1,650. So if mu is the true mean cost of rent in the city, the non-hypothesis is H0. Mu is equals to $1,650. Third, the alternative hypothesis is a claim we are trying to find evidence in favor of. In this situation, the economist tests if the average rent is now higher than 1,650, the average hypothesis in symbols would be HA, mu is larger than 1,650. So the correct answer is B. Okay, example number 3, the correct answer, I will pause the video and let you read it first. So the correct answer is A. First, we write hypothesis in terms of population parameters, not sample statistics. Thus, C and D are not correct answers. They should use mu, not X bar. Why should we should always state hypothesis in terms of population parameters, no X bar? So what's wrong with B? Because they are testing if the mean weight is statistically significantly lower than 250 gram. So the symbol should be less than 250 gram. So the correct answer is A. Okay, let's have some fun. Quiz number 1. Which of the following is correctly stated non-hypothesis? Please pause the video and make your answer. So the correct answer is A. Non-hypothesis states there's no difference between the population mean and some specified value. It is also referred to as hypothesis of no difference. Quiz number 2. Pause the video, please read it by yourself. So the correct answer is C. In general, the research hypothesis or alternative hypothesis is written as the population parameters is not equal to some specified value. So the symbol should be not equal, is non-directional. It's greater than some specified value or less than some specified value, is directional. The correct answer is C. Next question, please pause the video and read the question by yourself. So the correct answer is A, number A. Research hypothesis specifies that the population parameter is not equal to some specified value, greater than some specified value, or less than some specified value. Last question. Please pause the video and read it by yourself. So the correct answer is A. State the non and alternative hypothesis is the first step. Okay, take home message for the hypothesis testing. You should understand what is non-hypothesis and what is hypothesis testing steps and what is research hypothesis and the difference between non-hypothesis and alternative hypothesis. Okay, this is the end of this video. For the next video, we are going to go through each type of bivariate analysis. See you soon.